Okay, so I'm sure you're all familiar with the unit circle and how it works by now. The graph of sine of x, or sine of theta, is equal to the y value on the unit circle. So as we go around the unit circle, say once we get to pi halves right here, the coordinate of this point is 0, 1, and you can see that right here. And so the sine of pi halves is 1, because 1 is the y value. So if we go make a chart of theta versus y for the sine, so at pi halves, the sine or the y value is 1. Okay, let's fill in some more points. As we keep going, let's just fill in the easy ones. As we keep going around to, say, pi right here, the value of pi is 0. And as we keep going to 3 pi halves right here, the y value is going to be -1. And as we finish off to 2 pi, this point here can be represented by both 0 and 2 pi because it's repeating itself. The value is again 0. Okay, now we're going to graph the function of sine, where the x-axis is represented by theta and the y-axis is represented by the y value or the sine of theta. Okay, so if we review back to the points we found in the last slide right here, we find that the 4 points of theta we found were pi halves pi, 3 pi halves, and 2 pi. So those are going to be the points we plot. So pi halves, pi, 3 pi halves, and 2 pi. And then we're going to graph the corresponding values of y that we already found. So it starts at 0 and goes up to 1 at pi halves, back to 0 at pi halves, down to -1 at 3 pi halves, and back to 0 at 2 pi. And it looks something like this. So if you look at this graph, the graph never goes greater than 1 and never goes less than -1. So from the midpoint to either the trough or the crest or the trough, the amplitude of sine equals 1. Now, the period of any graph is the amount of time it takes to repeat itself. So when you're looking at the unit circle, it goes around a circle in 2 pi, or if you're looking at this graph, it finishes its cycle right here at 2 pi and starts where it began, at 0. So the period equals 2 pi. And if you look, this graph we drew looks the exact same as the graph when we plug it into the calculator. Right there is what we graphed.
So we're going to talk about how you can manipulate the sine graph from the sine equation. So first we're going to talk about horizontal and vertical shifts. So horizontal shifts are called phase shifts. So first we're going to look at sine of x minus 4. As you can see here, it's still the same sine graph. The only difference is you look at the inside here, and it does the opposite. So instead of moving to the left 4, it moves to the right 4 and starts at this point at 4. Good. The next equation we're going to look at is sine and then times 4x. So what you need to look at here is when you times it, it shrinks the graph. So instead of the period happening over 2 pi, it happens over 2 pi divided by 4. So this point right here where it's completed its cycle is at 2 pi divided by 4. Okay. Now we're going to look at when you divide by 4. So as you can see, it stretches the graph out. So if the normal sine graph has a period of 2 pi, you instead times that by 4, and now has a period of 8 pi. So this is equal to the point 8 pi. The last one we're going to look at to manipulate this graph is a vertical shift. So we have 3 plus the sine of x. As you can see, it's still sine of x, so still the same graph, you just have to move it up 3. So 1, 2, 3. And it starts right there, and then it's the same graph, the same amplitude, and also a period of 2 pi.
Thanks for watching.